Okay, this is our last lesson for matrices. So yesterday, or last lesson, we saw that we could solve a matrix by multiplying by the inverse of matrix A, we called it, since there's no division. One more way that we can solve is to use row reduction. So in this blank, fill in row reduction. We're going to use Gauss-Jordan elimination. Those are two men that came up with this. They were mathematicians. They came up with many more things than just this, but we're just going to focus on this today. It's just another way to solve a systems of equations. So we have so far substitution, elimination, graphing, and just using matrices to solve, but now we're going to use an augmented matrix to solve. So if, for example, I have a two-variable system here, I'm going to create an augmented matrix where we write the matrix as normal of the coefficients 2, -6, -3, 3. We're going to draw this bar here, separating this giant matrix with our outputs being 14, -9. It's assumed that there is two variables that we are solving for. If there was 3, then there'd be 3 variables, okay? 3 rows. So it's assumed that we're solving for x and y. When we were solving for matrices, we had a matrix here multiplied by a variable matrix equaling another numerical matrix. When we solved for our matrix, we received the identity, 1, 0, 0, 1. So if we multiply two matrices together and get 1, 0, 0, 1, in essence we have solved. Okay, we have isolated our variable matrix. So our goal here is to take this coefficient matrix and to have the coefficient matrix look like the identity. Because if it looks like the identity, then in essence we have solved. What's going to happen here is to compensate this looking like this, the numbers will change over here, and we will have a solution to our system. The beauty of math is we can check our work as well to see if our solution to our system is correct. So I'm just going to take this matrix, move it down here to solve. It says our goal is to perform operations to transform the coefficients and columns into the identity matrix. So we're going to begin with the first column. So originally we had 2, -6, -3, 3. And I think we have what, 14, 9? -9. Okay, so it says begin with the first column. To use row multiplication division to obtain the 1 entry. So our goal here is to make this into a 1 and this into a 1, this into a 0 and this into a 0. The easiest step is to get whatever entry you have here to a 1. All you're doing is multiplication. So how do I turn a 2 into a 1 with strictly multiplication? Well, we just multiply by 1/2 and apply it to row 1 and then we're done. So this is going to become 1, -3, 7. We didn't do anything to the second row, so we're going to rewrite the second row. Getting an entry into a 1 is the easiest process. The next step we would do is turn this into a 0. The idea here is to create 1s to knock out these numbers to get 0s. So then if I create this to be a 1, I'm going to knock it out to get 0 here as well. So it's going to be this U-shaped pattern. So if I have one here, great. I want this to be 0. If I just multiply everything by 0 here, I've ruined my whole entry. I've ruined my whole row with every entry and I'm done. So I can't use multiplication. However, I could use addition. If I had a +3 added here, I would get a 0. But where am I going to get a +3? You could borrow this row momentarily, or in essence, you could say you'll change the row and then change it. All right, so the easiest part is done. We have taken row 1, multiplied it by 1/2. Great. The idea here is to take 1s to knock out these 3s to create 0. So how am I going to knock out this -3 with just a 1? I can't just multiply this whole row by 0 because it'll clear everything. I need a positive 3 to knock it out. So I'm going to borrow this row. I'm going to take 3 and multiply it to row 1. Or in essence, you could say you could change it and change it back. So we're just going to borrow it. So I'm going to take the first row, multiply it by 3. And then I'm going to apply it to row 2. Row 2 is -3, 3, and 9. So I borrowed the first row, I'm applying it to row 2. So I actually haven't changed row 1. I've only borrowed row 1 and applied it to row 2 to get 0, -6, and 30. So right now we've got 1, and that 1 was able to knock out 0. Now we're going to move over to this one, this U shape, turn this into a 1 so that this 1 can knock out this number. So this is the next easiest part. How do you get -6 to become a 1? Just simply multiplication. Like I said, begin with the first column, use row multiplication. Okay, we're going to take a -1/6 times row 2. We have not affected row 1 at all, so we're going to rewrite it. Row 2 now is 0, 1, -1/6 times 30 is -5. So we hit 0, we get 1, we get 1, we get 0, we get 1. Now this 1 is going to knock out this -3. So we're going to do the same thing again. Whatever this is, we're going to multiply this to be the opposite. So we're going to take 3 and multiply it to row 2. But then we're going to apply it to row 1. So 3 times 0 is 0. 3 times 1 is 3. 3 times -5 is -15. When I apply it to row 1, it's 1, -3, and 7. We should get 0, our goal. So I applied everything to row 1, so I really didn't change row 2. Or you could say I changed it, but I changed it back. And then this row actually gets changed to be 1, 0, -8. So the beauty of math is that we can check our work. We got the identities, so in essence we solved to get 1. So our x value would be -8 and our y value would be -5. The beauty of math is we can check our work. Let's go back and check. Does (2 times a -8 minus 6 times a -5 give me 14? Does -16 plus 30? Yes, it does. Okay, if you want to continue and check with the other system, that's fine, but that should be sufficient. So then we have 2 more. We're just going to do the same thing again. So if you want, pause the video and try the next one on your own. Or if you want to watch it one more time, watch it one more time and try the other one on your own. Mr. Freed,
Yes, Mrs. Caserta.
would you like to do this last problem?
I would love to do this last problem. All right, kiddos. Let's turn our system of equations into an augmented matrix. So our coefficients are -1, -3, 4, and -2. Draw my line to augment our matrix. Now we have our current constants, -23 and -6. As Mrs. Caserta was saying, I want to turn this first -1 into a +1. How am I going to do that? I'm going to multiply the first row by -1. Dividing by -1 gets the same effect, but when we're working with matrices, we want to keep thinking always in terms of multiplication. I don't think I need to show this in an intermediate step. I think we can tell if I multiply everything by -1, I'm going to get 1, 3, +23. So I've accomplished my goal of getting my first entry to be a 1. Now I have 4, -2, and -6. I want to knock out this 4, so I want to apply the additive inverse of 4. So I need to take my first row, I need to take row number 1, multiply it by -4, and then add it back into row 2. So what's that going to look like? -4 times 1 is -4. -4 times 3 is -12. -4 times 23. Well, let's see. 4 times 25 would be 100. 23 is 2 less. 2 times 4 is 8, so I need 8 less than 100. Must be negative. So I need negative 92. All right, I'm not changing anything to the second row just yet. 4 minus 2 minus 6. So let's see, when I apply my first row multiplied by negative 4 to my second row, I'm going to end up now with the matrix. I don't really want to change my first row, or if I've changed my first row, I've now changed it back. 1, 3, 23. Negative 4 and 4 make 0. That was my goal. That's what I wanted to do. Negative 12 and negative 2 make negative 14. Negative 92 and negative 6 make negative 98. Okay, what's my next goal? My next goal is to turn this 14, or this negative 14, into a positive 1. At this point, I want to think about multiplying because I don't want this 0 to change. If I add anything, I'm changing the 0. So I strictly want to multiply. So let's multiply this second row. Let's take row number 2, and let's multiply it by the inverse of negative 14, negative 1 over 14. Or in other words, let's divide every entry in our second row by 14, by negative 14. So I'm not touching my first row. My first row is staying exactly the same. My second row, however, 0 divided by negative 14 stays 0. Negative 14 divided by negative 14 gives me 1. And let's see what we get here. This should be 7. 7 times 4 is 28. 10 times 7 is 70. 70 and 28 make 98. So I've checked my answer. I know I'm right. Last thing I want to do, I have a 1, I have a 0, I have a 1. I want this 3 to also be a 0. So now I'm going to think about adding the second row into the first row to make my 3 disappear. So I need to apply the inverse, the additive inverse of 3. So I need to apply a negative 3. I get that by taking my second row, multiplying it by negative 3, and adding it back into my first row. What does that look like? Negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 7 is negative 21. I'm applying that to our first row. 1, 3, 23. Okay, so let's see what our final answer is going to look like. I'm not touching the second row any longer. It's in the form I want it to be in. What's changed in our first row? 1 plus 0 is 1. 3 plus negative 3 is 0. That's what I wanted. And 23 and a negative 21 are going to give us a 2. So this tells me this system of equations, x is equal to 2 and y is equal to 7, is the solution for these two equations. As we say, math is beautiful, we can check our answer. Is negative 2 minus 7 times 3 negative 23? Is negative 2 minus 21 negative 23? But if it works for one equation, it also needs to work for the second in order for the solution to be true. Check for yourselves. Is 4 times 2 minus 2 times 7 negative 6? It is. So we know that we've come up with the right final answer. So the last thing that we want in terms of solving it using row reduction, it's the same idea that I want to first create a 1 in the top left column, top left entry. Instead of multiplying our first row and adding it into our second row, I'll multiply it by a number to apply it to the second row, multiply by a different number to apply it to the third row so that I can get zeros underneath. My next goal is to get this next one. I want to go down, work down the diagonals, multiply to get this one, multiply it and apply it to the 2 so that I can get a 0 here. Once I have a 0 here, I want to find a 1, multiply back until I get the identity matrix. If you have more questions, see us tomorrow during class, or if you need to, come to see us during tutorial. As a thank you for watching this video to the bitter end, if you come up to us during class and tell us this magic word applesauce, you can get a sticker. See you tomorrow.